Welcome to our next video for Stat 212. In this video we're going to just do some practice problems with confidence intervals for the mean, so using some of the ideas that we talked about in the previous video. Here we have a question. So researchers would like to estimate the average change in sleep duration for adults trying a new experimental sleep aid. So the researchers find that over the length of the study, the 47 participants report an average of 39 minutes more sleep a night while on the sleep aid. The standard deviation for change in sleep duration is 23 minutes. Assuming this is a representative sample of adults, use this information to build a 95% confidence interval for the average change in sleep duration for adults on this sleep aid. So a couple things here to note. First is this assumption, right? So notice how it says we have 47 people. We are assuming this is basically like a random sample of adults from the population we're trying to generalize to. It probably isn't truly random sampling. There probably are some external validity threats that we could talk about related to participant selection. So we're kind of making this confidence interval under the assumption that this is behaving like a random sample. So for that reason, we're typically going to say things like we assume it's a representative sample, that some method was chosen such that this should kind of imitate a random sample, and that we're kind of hitting the demographics in this population appropriately. So you might also notice that 47 isn't a really big number, and that's totally okay. We don't necessarily need to have a large sample. We don't necessarily need to have like hundreds of people in our study to be able to make these kinds of claims. And that's because these inferential methods that we're going to learn, like confidence intervals, are accounting for our sample size. So it knows that our sample size is 47, and that's going to affect how large our interval is. So the smaller our sample, the larger the interval is going to have to be in order to have some confidence. So don't be concerned about 47 as if we can't do anything with that. Our methods are accounting for the sample size that we have. Okay, so first, what is the formula for a 95% confidence interval? And by the way, I'd encourage you to pause and kind of think through these on your own first. You'll probably get more out of it that way, but I will go ahead and go through them. What is the formula for a 95% confidence interval? It's going to be x bar. So our template here is going to be x bar, our point estimate, plus or minus the z value for our confidence level, times the standard error of x bar. Now in our case, our sample mean is going to be 39 minutes. So we're seeing a positive 39-minute increase in sleep on average for this sample. Now obviously individuals are going to have different results. Some are going to have less. Some might even have less, like a decrease in sleep individually. But on average, if we look at our sample of 47, we're seeing a 39-minute increase on average. Now again, we're doing a confidence interval because we know that mu is probably a little bit different. Mu is probably not going to be 39, but hopefully x bar is a reasonably close estimate of that value, and we'd like to kind of quantify how far away it could reasonably be given this information. The 39 minutes, and we're going to add or subtract a margin of error value. So if we're going to do a 95% interval, then z for 95% is going to be 1.96. So we need to stretch out 1.96 standard errors in either direction. So we're going to do 1.96 times our standard error value, which we do need to calculate over here. So the standard error should be sigma over the square root of our sample size. Now, it says here that the standard deviation for change in sleep duration is 23 minutes. This is probably S. It's probably the sample standard deviation. So we're going to kind of assume that sigma is the same, and we're going to talk more about this coming up in one of these next videos. But for now, we're just going to pretend that sigma is 23 and not worry about this S versus sigma thing and how we account for that. So we're going to say that sigma is 23, and we're going to say that our sample size is 47. That we definitely know. So then kind of this expected error in our sample mean should be about 3.35, etc. So I'm going to say I'll round it to 3.355. So again, this is kind of the estimated error and our sample mean. This is how far we would kind of expect it to be off on average. We could have more error, we could have less error, but this is kind of an average amount of error. So if we want to be 95% confident that we're capturing the true mean, we need to stretch out 1.96 of these standard errors from our sample mean. So we're going to multiply that by 3.355. And then we're going to get an interval as our answer, right? So we're adding and subtracting this number. So we're going to get 39 minus 1.96 times 3.355. So our lower interval is going to be, you know what, I just realized I'm doing this all on one line, but I guess all of this is supposed to take place over these other lines, so I apologize about that. So this lower bound is going to be 32.42, and our upper bound is going to be 39 plus 1.96 times 3.355. And I get 45.576, or I'll just say 45.58. I'm sure I'm doing terrible rounding principles. There's probably correct principles I should be using for how many digits to round given information I have, but that's not really a priority in our class because we would just use software which would use all the digits that we have anyway. So this is more just kind of for the practice of doing it by hand and think about what we're doing, not necessarily about precision when we're doing it by hand. We just want to know how this works. So yeah, I kind of did this step here, so this right here, this went here, and then the interval bounds I did last there. Okay, so last we're going to interpret this interval based on our sample results. Are we at least 95% confident that there should be at least some increase in sleep duration for the general population as a result of taking the sleep aid? Okay, so first, we're going to write an interpretation statement, kind of a generic interpretation that we'll use for a lot of these. We are 95% confident that the average change in sleep as a result of taking this medication, so getting all this context in here would be nice, is between, and I'm going to kind of note here the positive, right, because like it could be negative in the context, so I'm going to be clear that these are positive numbers. So it's kind of a positive increase, 32.42 to 45.58 minutes. So we're 95% confident that that mu, the true average change in sleep as a result of taking this medication, is between 32 and 45 minutes. And again, this is not a statement about individuals. This is a statement about the population mean. It's a statement about a parameter. I still might see many individuals outside this range. In fact, I expect that many, if not most, individuals will have results that are outside this range. This is only an estimate of where the true parameter mu is going to fall in this population. Now, this follow-up question, based on our sample results, are we at least 95% confident that there should be at least some increase in sleep duration for the general population as a result of taking this sleep aid? So what I'm going to kind of say here is, notice that our interval is completely above 0, so it means that we are confident, at least 95% confident, that is. I mean, we're really more than that, but at least 95% since our whole interval is above 0 here. That mu is above 0, that there is at least some increase on average. Now, we can't make this statement again about individuals, so I wouldn't say that I'm 95% confident that 95% of individuals will have an increase. I don't know that, but I do know that the average increase in this population does seem to be between this range and certainly seems to be above 0. All right. Second question. A geriatrics researcher reported findings from her study that residents over the age of 80 who live alone spend on average only 24 minutes a day talking to another human being. She also reported that the 95% confidence margin of error is 4.8 minutes. What would be the 95% confidence interval for the average amount of talking time that solo living seniors seem to be getting? So this information is reported a little bit differently. This time we're given the point estimate, and we're just given what the margin of error value is. So we can kind of deconstruct this to figure out what this confidence interval is. So remember that a confidence interval formula is going to be x bar plus or minus the margin of error, which we could further break up to the z value and the standard error if we need to. But this is all we need for this one, right? Because we know that x bar is 24 minutes. The average in her sample is 24 minutes. And the margin of error appears to be about 4.8 minutes. That's how far her confidence interval extends for 95% confidence. What would be the 95% confidence interval? Well, I would just kind of deconstruct this again to 24 minus 4.8 is going to be 19.2. 24 plus 4.8 is going to be 28.8. So that would be her 95% confidence interval given this information. So if she wanted to have a smaller margin of error, what could this researcher do? And there's two things here that affect the size of the margin of error. So we talked about two of them. One of them is the level of confidence that we set, and the other one is kind of the sample size, or we could just call it the standard error. I think it's back here on this page, right? So we talked about two things. One of them is our confidence level affects how wide our interval is. Secondly, the standard error of our sample statistic affects how wide our interval is, and that has to do with two things: the sample size and the variability in the variable itself. So what we could do, if she wanted to have a smaller margin of error, is that she could just do a confidence interval with a little less confidence. So she could lower her confidence level So if she only wanted to be 90% confident, then the z value that she would plug in there would be like 1.65, and that would give us a smaller confidence interval overall. The other option is to increase the sample size. Because if we increase the sample size, then our standard error is going to go down. We're going to have more confidence in the sample statistic we're calculating, and we're going to have less expected error in that value. So then that also will decrease the margin of error. So those are really the two things that we have control of here. We can't really change the variability in the variable itself because that's just the variable that we're using, right? So that can't really change here. But these are two things that we do have power to change.